Welcome to MAEnow. We are here with our first faculty interview. Professor Mark Campbell, the S.C. Thomas Z. Director of the Sibley School of Mechanical and Aerospace Engineering. How are you?
I'm good. How are you doing, Joe?
I'm doing very well. We'll jump right into this. What is the uniqueness of your research? What sets it apart from other researchers?
So my focus in the robotics area is what I call intelligent autonomy. So I'm very focused or interested in the concept of intelligence, and I think of intelligence as really the smarts behind the robotics. So it's the ability to understand and reason about new situations that come up. That's really what makes us as people intelligent, that we can handle new situations like this.
Yeah.
And so my group typically focuses on theory and algorithms, and we take it all the way to the prototype stage. And so it's really nice to see it all the way end to end. That has a number of different benefits. So one of the biggest benefits is we can integrate undergraduates into the work. It also keeps the students inspired when you can actually not only see the theory and develop it, but you can also see it applied to an actual application like an autonomous car or a robot working inside of the lab. My advisor had this philosophy called the Sandbox Philosophy, which was you get some really good students and you get some really cool toys and you put them in the sandbox and you mix them all up and cool things will happen. And so I guess I've always tried to strive for that as a philosophy in creating an environment like that.
We're here at the Autonomous Systems Lab with Jen Padgett, Ph.D. student of Mark Campbell. How are you, Jen?
Good, how are you?
Good, welcome to the show.
Thank you.
Can you tell us a little bit about this robot that you've been working on?
So this robot is a Segway platform robot. We have outfitted it with several sensors. So for here we have a SICK LiDAR, which basically helps us find ranged objects. We have a few cameras here so we can do stereo vision. And we also have IMU, which basically helps us track wheels and how they move. And we also have a GPS sensor.
So the nice part about this robot, as you know, the base, you might recognize it, the base is based on a Segway, which is a people mover. They sell the base, and we have built basically everything from here up. And it's really been built by all of our students. I think the original vision of this was to create a mini Skynet that we could use indoors and outdoors. And so all the pieces that are on Skynet are really here also. So as Jen said, there's computers, there's GPS. There's a GPS antenna, so it can work outdoors. It can also work indoors in our lab in here. These are all home-built or student-built interfaces for all of our sensors. The computers are put-together components by the students. So these are some really good examples of student projects which have been built and evolved over time from students in the lab.
And you guys also do, you make all of the software as well, right? Not just the hardware?
Correct. So really the software is the focus of our research, and really what the PhD students work on. And so the nice part about this is that a lot of the undergraduate students work mostly on the hardware. And some work on the software also, clearly. But really the idea is that we would have these robots for the PhD students to demonstrate and validate any of the theory that they're working on.
So this is their theories in practice.
That's right. Exactly.
Right on. And what do you see? Either one of you can answer. What do you see the application of this robot? Now, present day, and in the future.
So we really see the future as kind of an interaction with humans. We would like to be able to have the robots naturally interact to solve complicated tasks. For example, we just had a group of students help a robot find objects in different rooms. And they did this with like a scavenger hunt type methodology where it will ask questions until it finds the object of desire. In the future, we see this going towards campus tours, for example, having an automated robot guide that can answer questions from an audience, having it go around campus, perhaps even automated snowplows.
So additionally, we can also, we've also worked a lot on search and rescue kinds of missions, both with the robots but also with people. And so we've actually done experiments across campus where we actually were looking for objects, cooperatively looking with teams of robots and humans working together, searching for objects Typically, what I like to search for golf balls in the winter and green eggs in the summer because it's a little harder to find, but it's typically a fun experience.
These can find those?
Yes, they can detect those with cameras.
Really? I couldn't.
It's actually harder sometimes for the people to do it.
Yeah, I bet.
Yeah, you get confused on egg rock.
Yeah. Thanks for the lab tour. Very awesome stuff.